This is the SOAPY speedboat experiment. Now it's quite easy to do. You're going to need some soap in the form of washing up liquid, and you can see here in my little tray I've got some washing up liquid. I'd rather not pick that up right now. You can see it in there nice, because I want to dip something in. In fact, what I'm going to be doing is dipping my pencil, so you do need a sharp pencil. You're just going to be dipping it in there, okay? So we'll leave that there for a minute. I'm going to use this tray, and as you can see I've already got water in it. You could do this in the sink at home, that'd be absolutely fine. I'm just doing it in a tray so we can see easily here. You need some cardboard. Now, only thin board, like postcard card is good. Thick paper can be okay, but I recommend card rather than paper, because card doesn't get so waterlogged and soggy so quickly. You can see here I've got a sheet of card from which I've cut a small piece, and I'm going to use that small piece to make the boat. Okay, now already you're going to see one design, but of course one of your variables straight away is the different design. I'll mention that again in a little while, but watch carefully the one I'm going to do. But remember, this is just one version. Okay, so I'm cutting the pointed end called the bow for the nautical people there. Okay, so the pointed end. Now I need to cut the engine. Now on the SOAPY speedboat you need a rather peculiar engine, as you can imagine. Now watch carefully the cuts. I'm going to make one going there. Oops, maybe a bit there. And I'm going to turn it there and do one there. Now what I've got here, that triangle shape I've just cut, when I bend that flap up and out of the way, will give me a triangle shaped space, as you can see. I'm going to use this piece. You could actually cut that off, but I'm actually going to hold on to it and lower the boat into the water with this piece, okay? So what we're going to do is, I'm going to ask you to make a similar one, and I want you then to get ready first with your pencil. If you're going to use a pencil, dip it in the washing up liquid. You don't have to have lots on there. I'm just there's a little bit coming off the end. Get ready with it. Keep it over here though. And then lower your boat into the water, and as soon as it's floating, I want you to come up with a pencil and watch what I go to do. Lower it in the water and touch in the gap. So, why should the boat move across the water in the way it did? Why should it happen like that? Just by putting a bit of washing up liquid. Now, did you notice my deliberate mistake? I dropped my washing up liquid just onto the back edge of the boat. I don't know if you noticed that. And it still shot forward. What I had asked you to do was to drop it actually into the little gap you'd made when you cut it with your scissors. But it will still work, as you've seen. But why, nevertheless, why does it go? Why should a little blob of washing up liquid make it shoot forward? Well, we need for you to understand about the surface of the water itself. Now, the surface of the water, where it meets the air, it forms a layer. And we can actually see that layer. If you were to put some water in a test tube or a thin glass and look, you'd see like a double layer right on the top. It's got a name, it's called a meniscus. Some people call it surface tension, but we've got to be careful, because surface tension isn't what it's called. Surface tension is what it does. It pulls in all directions. That's what it's called, surface tension. That's really useful to remember that expression, because that describes its main feature for us. That surface layer is pulling in all directions, that watery skin that I've described to you. We rested the boat on the top of the water. It was floating, and it was actually resting in that meniscus layer. Now, when I put the washing up liquid there and touched it, what washing up liquid does to water is it gets in between all the particles of water and gets in between them, and the water particles stick to the washing up liquid better than they do to each other. And by the way, water is wet because it's sticky, it sticks to things. So the water molecules and particles stick to the washing up liquid particles more easily than it does to itself. And that means that that surface tension that we see here doesn't pull as hard. Now think about it. I touch the boat, let's fish it out of the water here, but I touch the boat towards the back end. So the water touching the back of the boat, just for a brief instant where that washing up liquid touched it, was weakened. That surface layer was weakened and it wasn't pulling as much as it was before. Now one little example I could give you to try and make it a bit clearer is imagine that that boat had elastic bands, one in the front, one in the back. And you could imagine them all around it actually, but I want you to think about it. The one in the front and one in the back. The elastic bands are stretched, the boat isn't moving, but the elastic bands are stretched. Then we can think of the elastic bands and the way they're pulling, a bit like the water is pulling on the boat in all directions, and that's why it's not moving. Imagine what would happen if you cut the elastic band behind the boat. What would the boat do? Well, it'd be pulled forward by the other elastic band, wouldn't it? That's a bit like what's happening here. So when we touch the water with the washing up liquid behind the boat, the surface tension gets much more weak and stretchy. And in front, it hasn't been touched by the washing up liquid just yet, so that pulls harder and the whole boat is pulled forward by the difference. So what other things could you try? Well, again, you're very creative. I'm sure you can think of tons of things, but let me give you some things to think about. What about using different types of detergent? This is washing up liquid of a particular make. How about using different makes? So buy different brands and try those. What about other sorts of things like, for example, washing clothes detergent, the stuff you wash your clothes with, or any other sort of detergent, maybe those of you who have a dishwasher, you liquid in those, how about that stuff? Will that do the same thing? Do all detergents do the same thing? See if it does. What about the boat? I've shown you one design. I wonder what would happen if you made it a totally different shape. I wonder what that would do. I wonder what would happen actually if we used the same design and we touched the washing up liquid to another place on the boat. What do you think that would do? Of course, you've got to make a fresh one, and you'll have to get a fresh tray with new water. Every time you try something new with this particular experiment, because we've now got washing up liquid actually in it, we have to pour it away, clean the container, get all the washing up liquid out, put some fresh water in and do it again. But it is worth it, it's good fun.